Welcome to Control 4 Driver Development Essentials. My name is Peter Cosenza. In this video, we will walk you through the steps required to create a Control 4 driver for a door station or an intercom. This video covers both devices because door station driver development relies heavily on Control 4's intercom proxy. Essentially, a door station driver is an intercom driver. The only items that differentiate the two are the ability of the door station driver to capture keypad button presses from the physical door station. In fact, you may have already noticed that when you load a door station driver into a project, an intercom subproxy is automatically loaded as well. That's because much of the door station's functionality relies upon Control 4's intercom proxy. Due to the similarities between the two driver codebases, you will find this video useful to assist you with writing a driver for either a door station or an intercom. In this video, we'll use two tools delivered by Control 4 to assist with the driver creation. The first is Driver Editor version 3.0.1. This latest version of Driver Editor is a driver development environment that provides a graphical interface for the creation and modification of C4Z files. It is important to understand that Driver Editor 3.0 and all subsequent Driver Editor releases are compatible with C4Z files only. If you are new to C4Z files, we'll discuss them in the beginning of this video. The second tool we'll use is Control 4's latest intercom and door station driver template. Control 4 is currently in the process of delivering driver templates for many of its more heavily used proxies. Driver templates are delivered with Driver Editor. When a template is selected and loaded into the Driver Editor environment, it offers a powerful development scenario that can reduce development time as well as improve code quality. In this video, we will use a template specifically designed to help create door station drivers. In this video, and all videos found in the T201 series, it is expected that you be familiar with the architectural and development concepts outlined in the driver development training modules. This includes the 201, 301, 401, and T101 video series. You may find it useful to review the information offered in those training modules before proceeding to develop template-based C4Z files. Before we begin creating a driver for a door station, it might be useful to briefly discuss C4Z files. Beginning with Operating System 2.6.0, Control 4 has changed the file structure previously used to support device drivers. Up until 2.6.0, device drivers were contained within a single file using the extension of C4I, or drivername.c4i. The release of 2.6.0 marked a significant change to this model with the introduction of the C4Z file structure, or drivername.c4z. A C4Z file provides all the contents that the C4I file previously did. However, it offers some significant features and advantages that its predecessor did not. At its most basic level, a C4Z file is a zip file. It contains numerous folders and files which, when encapsulated inside a C4Z file, represents a device driver. The modularity within the C4Z file enables a far more organized and structured approach to device driver architecture. It also provides the ability to include many related objects within the confines of the driver in an organized manner. These objects include items such as graphics and icon directories to support custom user interfaces which can run on Navigator. A C4Z file also contains one or more Lua files, which contain all of the driver's Lua code. Control 4 driver templates take advantage of the C4Z structure by delivering libraries of commonly used Lua functionality. These can now reside in one directory location and can be easily referenced. A C4Z file also has its own XML file, which separates the XML portion of the driver from the Lua code. Additionally, rich text documentation can be included in the C4Z to support a far superior user assistance model. This DoorStation and Intercom driver development video is designed to be viewed in two parts. The first half provides an overview on two important components when developing a DoorStation or Intercom driver. The first component is understanding the role of Control4's communication agent. The communication agent replaced the Intercom agent with the release of Operating System 2.7.0. This agent is an important piece in configuring any device that supports Intercom functionality, including DoorStations. The agent is accessed and configured through Composer Pro. The second component worth discussing is the role of the SIP proxy and how your DoorStation or Intercom driver needs to interact with it to handle the communication setup and teardown phases of devices transferring data to one another in the Control4 system. This includes items such as DoorStations, Intercoms, and T3 touchscreens. The second half of the video will walk you through the use of Control4's DoorStation driver development template in the driver editor environment to create a functioning driver. Before we move into the component overview section, there are some items we need to consider. The first is the need to obtain the protocol information for the DoorStation or Intercom for which you wish to create a driver. It's important to obtain the latest protocol document from the device's manufacturer. It will provide you with the device's communication syntax and notifications it will send to the Control4's DoorStation proxy. If you are creating a DoorStation driver, something else to consider is the type of image streams your DoorStation supplies and whether or not they are compatible with Control4 devices. This is important as certain streams are not supported on every device running Control4's Navigator. For example, touchscreens prior to the T3 version only support JPEG and Motion JPEG streams. T3 touchscreens support JPEG, Motion JPEG, and H.264 streams. On-screen Navigator provided by the HC and EA class controllers support JPEG, Motion JPEG, and H.264 as well. So do the Control4 mobile apps. With this information in hand, let's take a look at Control4's communication agent and the use of SIP proxy and how they'll play a role in your DoorStation driver development efforts. As we mentioned earlier, the interface for the communication agent is delivered in Composer Pro. Its primary purpose is to manage all of the Intercom-based devices in the project. This includes DoorStations and Control4 touchscreens, in addition to any standalone Intercom devices. It's helpful to consider the communication agent as a database. It maintains information about all of the Intercom-based devices found in the project and communicates that information to Director. It also communicates directly to the SIP proxy, and we'll discuss the significance of that in a minute. Now, let's take a look at the agent in Composer Pro. If we go to the Agents area in Composer Pro, we can see the communication agent. If you do not see the agent, you can add it by clicking the Add button and selecting it from the list provided. We can see that the agent UI is broken up into several areas. The Device Properties area lists all of the Intercom-based devices in the project along with their respective device ID, location, and state. The device state pertains to the current communication status for the device. These statuses include Not Ready, which means the device has not been identified by the SIP proxy and cannot participate in calls. Idle, which indicates the device is not in use and can participate in calls. A status of Busy indicates that the device is in use and cannot participate in calls. And finally, a device status of Max Calls means that the device is already in more than one call, one active and one on hold. Therefore, another call can't be made. Intercom-based devices can also be grouped within the communication agent. This is useful and can assist with managing what intercom devices will be contacted when a visitor uses the door station. For example, we can create a group called Guest at Door and then assign any intercom-based device to that group. Now, if we go to the Properties area for the door station, we can select the Guest at Door group. Now, when a visitor presses the doorbell button on the door station, only those intercom devices assigned to the Guest at Door group will be called. The Device Properties area of the communication agent also allows a dealer to place intercom-based devices in an order by using the Move Up or Move Down buttons. This order will dictate how the devices are displayed in Navigator. The manual answer timeout value allows for a set amount of time in seconds that is provided for the intercom call from the door station to the touchscreen to be answered before timing out. As we mentioned earlier in this video, the Session Initiation Protocol Proxy, or SIP proxy, also plays an important role in supporting intercoms and door station drivers. In IP telephony, there are two data sets involved when IP-based devices attempt to communicate to each other. The first data set can be considered configuration data. This data includes the information required to establish a connection between the devices and subsequently tearing down that connection when the call ends. The role of the SIP proxy is to manage this configuration data set. In the case of this video, that will be a connection between a door station driver and a touchscreen driver. However, it could be between any device that uses Control4's intercom proxy. The second set of data involves the actual communication packets between the two devices. It's important to understand that the SIP proxy doesn't care about that data. Once our door station and the touchscreen can communicate with each other and are in a position to transfer voice or video packets between each other, the job of the SIP proxy is done. Before we go further, an important concept to understand in door station driver development is the process behind your SIP-enabled door station registering with the SIP server. Without successful registration, communication between the door station and Control4 user interfaces is not possible. In this section of the video, we'll look at two ways to accomplish the registration process. The first example assumes your device has a means of SIP registration that falls outside of the device driver and the Control4 operating system. Say, for instance, that this is a web service that handles the registration. The second example involves using the driver you are writing to initiate the SIP registration process when the door station is successfully identified in the project. Let's look at the first scenario. In this example, the registration process starts at the intercom door station device. Keep in mind that SIP isn't a Control4 construct, and since a SIP-based device inherently knows how to communicate with the SIP server, registration is initiated at the device level. The device needs to send a registration request to the SIP server. This can happen in several ways, such as entering device information into a manufacturer application page. Once the SIP server receives the request, it in turn sends a response to the device, and at that point, the device is registered. Something to keep in mind with this example is that since the process occurs outside of the Control4 system, no Control4 UIs are updated to confirm the registration process. However, you can use the actions provided in Composer Pro to verify registration. If you click on the Actions tab and click Idle, you can see that the room where the device resides has now become available for a call. This is telling the Control4 UI that the device is ready. If you hit Not Ready, the room is grayed out in the UI. This is a valid way to sync the Control4 UI with your device's SIP registration status. Now, let's look at how an Intercom door station driver can initiate the registration process. Below is how a driver may work using the identification process to trigger registration. When the Intercom door station device is identified in a project by a dealer, it comes online and an initialization function provided in the driver template is called. That function is named onNetworkConnectionChanged. OnNetworkConnectionChanged calls a function supplied by the template named initialize. Your job as a driver writer is to complete this function to have your device send a registration request to the SIP server. When the registration process is completed, it is assumed that the door station device will send a message to the Control4 system indicating the registration status. The door station template includes a function named devMessageCurrentStateChanged that can be modified to process this message. Earlier, we mentioned that the communication agent and the SIP proxy communicate with each other. The device data managed by the communication agent needs to be shared with the SIP proxy. The SIP proxy relies on this data to set up communication between devices when they are available, referred to as idle, and prevent communication between devices that are not available. Not available states include not ready and busy. As previously mentioned, once the door station and the touchscreen can communicate with each other and are in a position to transfer voice or video packets between each other, the job of the SIP proxy is done. Let's look at this using an example of a visitor to a home with a door station and a Control4 touchscreen. When the user presses the doorbell button on the door station, a command is sent from the door station to the Intercom proxy. You'll notice that when a door station driver is loaded, the Intercom proxy is loaded as well. The command tells the Intercom proxy to start a SIP call. This is referred to as an invite. Along with the invite, the command includes a unique SIP address of record, or SIP AOR. The AOR is for a SIP endpoint that will subsequently receive the invite from the door station, or the touchscreen in this case. Here are some examples of valid SIP AOR syntax. Let's look at some high-level data flows to understand what happens when a user presses the doorbell button on the door station and a Control4 touchscreen inside the home subsequently handles the door station button press. When the button is pressed, a message is sent from the door station to the door station driver. In this example, the message is named outgoing call. It's sent within a DriverWorks API named received from network. The door station driver needs to handle the incoming outgoing call message and change it if necessary so the Control4 Intercom proxy can understand it. Once that happens, the door station driver sends the notification to the Intercom proxy using another DriverWorks API named send-to-proxy. At this point, the Intercom proxy knows that a call from the door station has been initiated. It relies on information managed by the communication agent to verify if the device state of the touchscreen inside the home can accept a call. If so, the communication agent alerts the SIP server of the call. The SIP server then initiates a SIP invite to call from the door station to the touchscreen. When the touchscreen receives the SIP invite, the doorbell chime is played. The camera feed, if available, is displayed on the touchscreen, and the option to accept or ignore the call is provided on the touchscreen. To continue this data flow, or when a user of the touchscreen answers the call, when the UI answer button is pushed, a message is sent from the door station to the door station driver. In this example, the message is named call accepted. And now we will complete this data flow example. When a user of the touchscreen ends the call, when the UI End Call button is pushed, a message is sent from the DoorStation to the DoorStation driver. In this example, the message is named Call Ended. The DoorStation driver development template has all of the Intercom proxy and SIP proxy API calls plumbed and ready for your use. Before we get into actual DoorStation driver development, there is one point that's worth mentioning with regards to the SIP proxy. The SIP proxy has the ability to support video streams between two SIP devices. While this is a convenient way to have two devices communicate with one another, it limits those video devices from communicating with non-SIP devices in a Control4 project. By using Control4's camera proxy in your driver, you can enable the DoorStation to interface with all devices in the project that support telephony communication. However, the use of the camera proxy is beyond the scope of this video. For more information on using the camera proxy, please refer to the driver development training video titled Template-Based IP Camera Driver Development. Hopefully you found the overview part of this video useful in your efforts in writing a DoorStation or Intercom driver. The flexibility of Control4's Intercom proxy, along with the roles played by the communication agent and SIP proxy, present a driver development scenario that is unique to Control4. Having an understanding of the key architectural components in play will make your driver development experience easier. Key takeaways from this section include knowing that the Intercom proxy is used by all device drivers that support telephony communication. Understanding that the role of the communication agent is to manage important data for each Intercom-based device and share that with Director and the SIP proxy. The SIP proxy does the work of building and breaking down connections for your driver. In the next section of this video, we'll work with the DoorStation and Intercom driver development template to write a driver that supports DoorStation functionality. You should know that the template already has all of the needed code for you to take advantage of the communication agent and SIP proxy. Now that we've taken some time to understand the driver architecture behind DoorStations and Intercoms, let's go into Driver Editor and take a look at the new driver development template and review the steps necessary to create an Intercom or DoorStation driver. From within the Driver Editor toolbar, we'll select File and hold our mouse over the New menu option. Here, we are presented with several choices. In this demonstration, we're going to create a new project, or C4Z file, based on an existing template. So we'll select the Driver Project from Template option. When we do so, we can see the Intercom and DoorStation proxy template. Selecting it loads the template into the Driver Editor environment. At this point, it's worth explaining a Driver Editor construct that is important to understand. Driver Editor 3.0 views C4Z files as a project. When a C4Z file is loaded into its environment, Driver Editor organizes the C4Z into a structured project and displays it in the Driver Project window. Due to the organized structure of a C4Z file, it's easier to consider our driver as a project while working within the Driver Editor 3.0 environment. This is also a good time to discuss where Control4 driver templates reside on your system. Driver templates are delivered by Control4 through the Driver Editor development environment and will always reside in the following directory: C, Program Files, Control4, Driver Editor 301, Templates. You will also find a driver template directory in this location: C, Users, Username, Documents, Control4, Driver Templates. This directory is created for you to store driver templates that you have customized or created on your own. It is important to keep these templates separate from the Control4 supplied templates, as the driver editor templates directory is overwritten upon an update of driver editor. Along with the template's overview documentation, you'll also notice the driver project area of the screen. Here is where we can see the project framework that is provided through the Intercom and DoorStation template. At first glance, it may seem like there are lots of files and directories. However, it's actually numerous Lua files organized by purpose. You'll note that some of them are in libraries as well. Here is our driver's XML file and also a driver documentation in a rich text file. If you are familiar with the C4I file structure, you'll remember that all of this would have previously resided at one level within the confines of a single C4I file. If you want to open one of the Lua files in the project, simply click on it and its contents are displayed in Driver Editor's editing window. For example, let's open the project's main driver.lua file. This file is significant as it contains all of the require statements for our driver, as well as the initialization code that is executed when our driver loads. We can also see our driver's XML content in the window by opening the driver.xml file. When we double-click the file, we can see the high-level XML in the driver configuration window. Many of our driver's XML information is edited by double-clicking on any of the top-level elements. This displays Driver Editor's XML editing screen. Here, numerous XML entries can be modified and easily saved in our driver project. The more complex XML elements can also be opened and edited in the driver configuration screen. For example, if we open the proxy's XML entry, we can see a high-level view of its contents. Double-clicking on the proxy value will display the proxy editing screen where changes can be made and saved into our project. You will find that the UI in Driver Editor presents XML based on the data types and amount of data that a particular element contains. For example, if we go into Capabilities and double-click on the is_DoorStation element, the Driver Editor screen will display a window to view or edit any of the capabilities. Let's go back into Driver Project and look at one more file. Notice that I can toggle between Driver Configuration and Driver Project by using the tabs at the bottom of the Driver Editor screen. Here is the documentation.rtf file. Double-clicking on the file opens an editing screen which supports rich text formatting. Font assignment, images, and hyperlinks are all supported in this area. This provides you with an excellent opportunity to deliver quality driver documentation to integrators who are using your driver in commercial or residential systems. Now, let's begin to modify this template and turn it into a publishable C4Z file which supports our Intercom or DoorStation. In this section of the video, we'll show you examples of each of the development steps to complete the driver. These include handling proxy notifications from the Intercom proxy to the Control4 UI, handling proxy commands from the Control4 UI to the Intercom proxy, updating the XML for the driver, adding documentation to support our driver, building the driver in Driver Editor, validating the driver in Driver Editor, and finally, publishing the finished C4Z file. To start, let's look at handling data flow coming from our Intercom or DoorStation to the Control4 user interface. We call these data messages notifications. All notifications sent from our DoorStation need to be parsed into a format that the Control4 Intercom proxy can understand so that they can be handled correctly by our driver. Because we have the DoorStation's protocol documentation, we have a good idea of what these messages will be and how they'll be formatted. Your driver receives communication from the door station through the device messages.lua file, specifically inside of the getMessage function. The communication is broken into logical chunks and sent to the handleMessage function. HandleMessage is responsible for taking the communication block given to it by getMessage and identifying it into a unique function and parameters. Once this is done, those pieces are now sent to dispatchMessage, where the appropriate driver developer created devMessage function is called to issue the correct calls to update the state information of the system. Also in this file, we can see that all of the Intercom proxy notification handler function calls are provided. Keep in mind, there's no need for us to edit any of these function calls. Rather, they will be called after we parse the message from the device and create the new function. Our new function will call the appropriate predefined notifications, which is then sent to the proxy using the Send to Proxy API. Let's take a step back and see how this happens. Once again, all parsing of messages from our door station happens inside the device message.lua file. If we open the file, we can see that a sample function has been included. It's called devMessage.callEnded. This function is called when a user presses the UI End Call button. Your job as a driver developer is to parse the incoming message from the door station into a format that can be sent to the Intercom proxy and subsequently notify the proxy that the call has ended. Keep in mind that if your door station sends multiple messages within one response string, each message will need to be parsed into a single function for processing inside of getMessage, and then sent to handleMessage in the deviceMessage.lua file. Let's consider a message that comes from the door station in our example when a call has ended. The incoming message from the door station looks like this. Without modification, this means nothing to the Intercom proxy. We need to parse the incoming call ended message into a name-value pair, with name being the command from the door station and the value being its parameters. Once the data is correctly parsed into a name-value pair, we'll use the devMessage.callEnded function here to send the value of the call ended message to the Intercom proxy so it can be handled by our driver. The proxy class defined in the Intercom proxy class.lua file provides a template API or a group of functions that can be called by devMessage.callEnded. These APIs are recognizable by the Intercom proxy and can pass the call status data onto our touchscreens in the project. The names of these API functions begin with dev underscore. For example, here is the function for handling a door station call being ended. It's called dev underscore call underscore ended, and it takes values for device ID, session ID, and hangup type. Knowing this, we need to go back into deviceMessage.lua file and modify the devMessage.callEnded function to look like this. Once we have handled all of the messages that the door station sends that required being sent up to the UI in this manner, we can move on to handling proxy commands. Now, let's change directions and take a look at communication flow coming from the Control4 UI to the Intercom or door station. When we refer to Control4 UI, we're talking about the initiation of an Intercom-based message being sent to the door station or to another intercom from user interaction through any device running Navigator or Composer Pro's control. For example, this could be a T3 touchscreen. We call these messages proxy commands. When a message is initiated, it first calls Control4's Intercom proxy. The proxy then calls into the Control4 API received from proxy, which in turn calls into the intercom proxy commands.lua file using the prx_cmd command table structure. Intercom proxy commands.lua is a template file that receives the command from the intercom proxy and handles it for you, the driver developer, by modifying its format as well as its parameters. For example, the intercom proxy commands.lua file then calls into the intercom proxy class file. This is a template file that stores device-specific data within the driver template. It receives the modified command and extracts its tparams table into one or many individual parameter elements for you. In doing so, it also modifies the format of the command further. For example, this modified version of the command is then delivered to the proxy commands.lua file. Here is where you, the driver developer, needs to receive the command and its parameters, modify them in a manner that is valid for your intercom or door station, and subsequently send the command to the intercom or door station via its designated communication method. Now, let's take a look at an example of the functions that are included in the proxy commands.lua file. In doing so, you will also see how the template uses Lua tables to store most of the data required to build functional commands. By using tables in this manner, we're able to keep the actual function code in small, easy-to-read blocks. Here we see the accept call function as it is delivered in the template. You will notice that the to-do line indicates that you need to provide the values used by your intercom or door station for accepting a call. A value needs to be placed within the quotes for the local variable named command, which represents the intercom or door station's protocol command for accepting a call. By referencing our device's protocol documentation, we know that the following string is assigned for accepting a call. This string is entered between the quotes for the local variable named command. Our code for the accept call command now looks like this. You will need to enter the correct protocol strings for any functionality that your intercom or door station supports, such as end call, accept call, reject call, and pause call. Once we have handled all of the proxy commands, the Lua development work for our driver is complete. Now, let's look at the XML portion of our driver. As we stated earlier, there is only one XML file in our project, driver.xml. Note that the driver XML file name cannot be changed in the template, as Driver Editor expects a driver.xml file to be present when it builds our C4Z file. That file is edited through the driver project screen on the right-hand side of Driver Editor. The example door station for which we'll be creating a driver in this video is the Acme door station, so we'll change the manufacturer and model fields to reflect that. Next, we'll name our driver. This entry is important as it will be displayed in places where users will be looking for our driver. A driver name should be descriptive and informative. We'll name this driver Acme Door Station. We'll leave the creator value unchanged for our purposes, but this entry could be a developer name or company name. Next is the version field. Since this is our first iteration of this driver, we'll leave the version at 1. However, you can start your versioning as you see fit as long as the version numbers used are integers. We can also update the created entry. This is useful as it provides a date stamp when our driver development was initiated. You can modify the time and date elements by highlighting each and using the arrow buttons. You can also set the field to the current date and time by clicking on the plus icon. The modified field functions similarly to the created entry and offers you a way to assign a time and date stamp to future driver modifications. We'll set our modified value the same as our created entry. You can also set the modified date element on a system-wide level under the Tools Options menu. Select Dates, and you are presented with three choices for how the modified date field will be populated: manually, as we have just demonstrated. Upon saving a driver, the modified field will be updated, or you can choose to have the field updated upon publishing the driver. Those are all of the changes we need to make to the main XML page for our driver. All of the remaining values are set correctly by default for us from the DoorStation proxy template. At this point, we've configured all of the high-level XML information for our driver. Next, we'll quickly take a look at proxies. We verify that the DoorStation proxy is already added for us, so there's nothing more we need to do here. Next, we will take a look at the Connections tab. You will notice that the template has three pre-populated connections: one for the DoorStation proxy, one for the Intercom proxy, and one for the TCP network connection. Also, if we open up the Classes section, we can see that the correct class name is already provided. The template supplies all of the necessary connection information for our driver by default. Finally, we'll include some documentation with our driver, which will help integrators with setting up and configuring the DoorStation. To do that, we'll open the documentation RTF file and either copy pre-existing content into it or create it right inside the window. This content will be displayed in Composer Pro under the Properties Documentation area for our driver. At this point, we've reviewed and modified all of the key components of our driver project. Driver Editor provides several tools for us to finalize the project and eventually publish it as a working C4Z file. The first step in this process is building the C4Z project file that we've been modifying. The build process does several things. First, it saves all of the files in the project. Then it creates a C4Z file from the list of files found inside the driver editor under our C4Z proj file. To build our project, we'll open the Project tab from the toolbar and select the Build option. Alternately, you can use the shortcut key of F6. When the build of the project is complete, the output window is updated with the results. The next step in our process is to validate our newly created C4Z file. It is important to understand that a project must be built before it is validated. If you select Validate before building, Driver Editor will force a build of the C4Z proj file to create a C4Z and then perform the validation. The validation step is useful as it leverages a set of generic tests supplied by Control4 and delivered within Driver Editor, which reviews the driver XML file for correct XML structure and valid content. It also compiles all of the Lua files and validates them for correct syntax. To validate our C4Z file, once again open the Project tab from the toolbar and select Validate. F7 will also initiate the validation process. Before validation begins, you can set the verbosity level of the validation process, as well as the level at which logging will be displayed in the output window once validation has completed. Verbosity level gives a listing of the tests that were performed against our driver, as well as their status of pass or fail. Let's select the Most option here, as this setting will provide us with additional information in the event that a test fails. We'll select Debug Logging Level, as we'd like to see any log content that will help us figure out where an issue may be within our driver. Clicking the Validate button begins the process. Here we can see the log file contents of our C4Z validation. The log shows us all of the tests which were run against our XML and Lua code, as well as the results. Using Driver Editor, we've built a C4Z driver from our C4 proj file. Next, we validated the C4Z for invalid content. Now, we are ready to publish our finished DoorStation driver. The Publish function in Driver Editor is useful as it places the finished C4Z file in a designated area which can be devoted to completed drivers. You can designate this directory by clicking on Tools from the Driver Editor toolbar. Select Options followed by Workspace. Here you can designate a target directory for your driver project directory. This is where all of your driver projects are kept before they become C4Z files. The Build directory allows you to designate a place where your drivers can be built and saved as you make changes to the driver's code. Finally, the Publish directory is where your completed publishable drivers will reside. Having a different Publish and Build directories allows you to make changes to a driver that is maintained in the Build directory while still providing a published version of that same driver. This concludes the template-based Intercom and DoorStation driver development video. We hope that you found the information presented here informative and helpful in assisting you with developing Control4 drivers for door stations and intercoms.